An emergency simulation at an experimental laboratory at the University of Luxembourg's Interdisciplinary Centre for Security, Reliability and Trust. A person, alone at home, has suffered a dizzy spell and fallen, and sets off an alarm via a transmitter. Permanently installed cameras are activated and quickly detect that the person is unable to get up again. An electronic helper is woken and talks to the person reassuringly.
Dear Annette, I received your request for help. I am processing it. I try to contact Mike.
Simultaneously, trusted persons are notified of the emergency by SMS or instant messaging and receive an access code to a safe with the key to the flat. This code is valid for one time only, ruling out any possibility of later misuse.
Hello? Has the test went well?
Yes, great.
The experiment was a success. The team of devices communicated together swiftly and flawlessly. In a real emergency, help would have arrived soon, in some cases a matter of life and death. Monitoring of this kind can provide additional safety, both for the severely ill and the frail, and enable them to continue living at home.
The complicated part in this demonstration is to make all the different devices communicate and work together to create a value-added service. So to do that, we developed, and we still are developing, what we call the component-based framework, which is called CoPAINS, and which is a software engineering tool to be able to really make all these devices be integrated into one application.
The project is part of the SNT program, Conviviality and Privacy in Ambient Intelligence Systems, or CoPAINS for short, in which the researchers are developing technical care systems that can be easily integrated into people's everyday lives, not least in order to provide answers to urgent demographic questions.
In Europe, this is a crucial point because the population is aging, so we need definitely to have some systems which can help people live a quality of life at home, and also a social security system which can be sustainable, meaning that it cannot be explosive in terms of costs.
The experts are already simulating the next developmental stage of such networked care systems on the computer. In this scenario, a humanoid robot autonomously recognizes the emergency situation and calls for help. At the same time, it comes close to the person in need of help, soothes the person, and allows an outside physician or health service to talk directly via the robot to the person. An entirely realistic vision, as initial tests with a real robot demonstrate.
Do you need me?
Yes.
Yes.
The challenging part is that robots like Nilou here have to be able to navigate through the house fully autonomously and learn to see, hear and speak.
Patrice, are you okay?
No.
No. Don't worry, I'm contacting emergency right now.
Great. The difficulty with robotics is that people are seeing a lot of excellent science fiction movies. For example, they have special effects which are fabulous, so you see robots doing this thing, that thing, everything looks normal and fantastically articulated. They think, they react, they take decisions, but this is very far from where we are at in the real world. When we do robotics, this is a lot of coding, implementations, a lot of hardware problems, and so it is far from what we see in science fiction. Okay.
And yet, through the use of complex artificial intelligence techniques, even little robots like Nilou already come across surprisingly human-like. A task which requires an enormous amount of theoretical research to reach this level of professionalism, including software testing and security and privacy enforcement techniques.
You want I sit down?
Yes.
Yes. Yes, I will sit.
Good job. Okay.
A first glimpse at the future coexistence of man and robot and the result of many years of work.
Very good, Nilou. Good job. Thank you.
If you consider 15 years ago what was a phone, we have evolved from a phone to something that is much more than a phone, but that is still called a phone in some way. And I think the evolution for the flats will be the same. We call something a flat today. In 50 years we call it a flat or a home, but the difference will be very similar to the difference between the old, I would say 15 years ago, phones with the new smartphones. We will have a smart home that will provide so many added services that we cannot even imagine them. And maybe the only contact point with these hidden services will be the companion, the robot, or some artifact that will interact with us, that will be the pet, the technical pet we will have for our everyday life.
All of these technologies collect sensitive data, which must never fall into the wrong hands. Accordingly, the researchers must program the software so securely as to prevent any intrusion into the systems. Only then will people accept these technologies as a useful aid for their everyday lives.
One of the key issues is the ability we have now to collect very large amounts of data and to understand how people behave, for instance, in order to provide better services, but also it could be used in a bad way by bad guys for instance, trying to understand when people are there, when they are away, when they can go inside the flat, etc. The point is to control the way the data are used externally to the home, to the building, or to the city, or to any system. That's a key aspect, I would say.
Smart homes and robots will accordingly shape our everyday lives to an increasing degree in future. They can make our lives easier and perform many helpful services.
Do you need me?
Now,
Of course, they must forever be at the service of mankind.
No. Okay, bye-bye.
And that means people decide when they are needed and when they're not.
I will even shut you down.